So what are the different stages we supposed to follow for this particular precision spraying? So here I have taken 3 steps. The very first one is we want to capture the image from the field, and whenever I'm going to take an image from a field, it is going to be like your background. You may have your soil. Then in addition to that, we are going to have the plant. So here plant is nothing but that includes your crop, and that is your crop and the weed. Okay. So we want to segregate the plant and the background. So that means your weed and crop is one category, and the background, that is nothing but your soil, is another category. So through your excess green and excess red, it is possible to segregate it. So by using this formula, excess green and excess red, it is possible to segregate your background and the plant. Okay, now I am having the plant. That plant has 2 parameter. One is your crop and another one is weed. So we want to segregate our crop and the weed. So that is the another stage we supposed to follow. So if you take crop like your turmeric, banana, or your what is that sugarcane, the leaf area will be more. Okay, so through area based classification, it is possible to segregate your crop and weed, so that you can identify which one is weed, which one is crop. So after identification of this, okay, now I know weed is there. So now in an image, there is I classified weed and crop. So now I have taken only the weed alone. Okay, now the weed may get spreaded in different areas. That means you may have some 2 to 3 leaves. So we want to find out where exactly it is located. So we want to go for the region-based drops in order to find out the centroid of that particular weed. So after finding of that particular centroid, then we supposed to take X and Y position of that particular weed. So once if you are obtaining that X and Y position, okay, you can send that information to your controller, so that the controller is going to activate the corresponding nozzle. So here the image size which we have taken here is 640 cross 480 pixel. Okay. So now I want to do all this process as an autonomous process, not a manual process. We want to make it as autonomous. So for row-based crops, we are going to have furrows and ridges. So based on number of furrows and ridges, we want to make an algorithm so that your robot is going to travel in a correct direction and in correct manner. So here we have developed an algorithm to track your furrows and ridges. So this is your simple pictorial representation of how the robot gets moved. Maybe in your video it is very simple to understand. So this is actually a developed model. So it consists of, this is your water tank, that is nothing but your pesticide control element, or maybe your nutrition control things you can keep it here. And you may have like your camera. This is a solenoid valve to activate nozzles. We have taken only 4 nozzles because 1 to 1.5 feet may be the area where you can travel. That is the robot can travel. So this 4 nozzle is enough to cover that particular area. And we have 4 different wheels. 4 wheels are independent wheels because we want to make different actions while traveling. So through your pump, we are getting the pressure. So through that pressure, we are spraying the chemicals. Okay. So the processor we have taken here is a Raspberry Pi. And in order to identify the ridges and furrows, we have used ultrasonic sensor. In addition to that ultrasonic sensor, we have used accelerometer to identify the position of your robot, because this is not going to be a robot which can travel in a what is it, smooth surface. So we supposed to operate this particular robot in a rough surface, that to soil and different conditions. So we want to we want to adjust the position of robot based on parameters. So that's why we have included that accelerometer. So let us see the video demonstration of that particular developed model. So initially we have developed that model and we tested in a laboratory. So in 3 sites, we kept ultrasonic sensors to detect that furrows and ridges. So in order to make automatic travel path. So after that, we tested without any crop and other element. Just we made artificial furrows and ridges. So actually we have used only the proportional controller. Suppose if there is any integration of your PID controlling process, then the turning process may be a smooth one. So before start of this process, we supposed to give how many ridges and furrows are there in that particular thing. Then automatically it is going to do that navigation process. But the condition here is in both the sites, we want to have equal number of ridges and furrows. So once it gets completed the given task, then it will come out of that particular area. Okay, this is actually without any disturbance. That is maybe if you take the soil conditions, sometimes we may get dry, sometimes we may get wet. So running that robot in a dry condition is very simple, but running that robot in a wet condition is a tedious process. So that also we tested with uh, some changes in the soil. And finally, before getting to the actual process, we have tested without any load, how it is going to move. So if you see here, this is actually a simple setups we have made. So this is without consideration of your situations, that is whether the weed is present or not. So normally the farmers used to apply the chemicals throughout this particular area. So here, the this particular robot is going to detect the weed, and it is going to spray the chemicals only on that particular selected area, not in all the areas. So actually, we faced a lot of problems while moving wheel under different environment conditions because of like small stones and other disturbance. So that's why we made it as a chain based one. So finally, we have developed this under this chain based control. So one of the drawback with this particular system is it is going to take some time to recognize. Okay, even in the video itself, we could able to identify how much time it is going to take to identify the weed. So if there is any algorithms or any kind of processor which can do the image processing tool very faster rate, so that will be very good one for faster completion of the task. Yeah. So the next one which we have developed was chlorophyll meter. So I think everybody knows about this chlorophyll. So for better